that much importance Hive has. Uh, Hive, another point is Hive is very, very easy to learn. And most of the Hadoop committers, okay, like those who are building the Hadoop platform, uh, they're all Hive favorites. Okay, like I could say they're all in favor of Hive because they thought it a lot. Okay, like while adding the Hive into the Hadoop ecosystem. So Hive is never going to die in the Hadoop, at least in the Hadoop ecosystem, or whenever the big data platform survives, Hive also would survive. Okay, like so, and it's very, very convenient, and I could say because of Hive only, Hadoop has become very, very famous. If Hive is not there, I don't think Hadoop or Big Data would have become that much famous. Okay, like so Hive, because of Hive only, it become very, very famous, and also because of Hive, Hadoop has reached a lot of people. Okay, like, and most of the business needs, or even the people, management people, saw the huge advantage of the Hadoop platform. And without the Hive, I, it's very hard to visualize the advantages of having the big data or even Hadoop platforms. Okay, so that's what Hive is very, very important, and also it's very easy to learn. Um, Hive provides, maybe let me go to the next slide. Okay, Hive provides a platform or a system for managing and querying the structured data stored in HDFS. Okay, so Hive provides, in short, Hive provides a SQL interface to run queries against the data which is stored in HDFS. So in the last class, we saw that some of the HDFS file system commands, okay, like using that you could play around, you could copy the data into HDFS, get the contents of the HDFS, and move the files from HDFS, remove the files, copy the files, and all these things, right? So now we are in a stage how to copy the data into HDFS. So all of you, I think, you are pretty much um, familiar about the process, how to store the data into the HDFS. Next thing is how you could manage. So storing into the data is one step. Second step is how you would manage and how you could provide this data to others. So how others would consume this data. Not everyone would be able to run the HDFS command, right? If I want to see the file system contents of a file stored in HDFS, it's not easy always. Okay, always people will not log in into your edge node of your Hadoop platform and then run some HDFS commands. It's not easy. It's not feasible at all, right? So how would address that gap by providing a SQL interface. So SQL is um, I'm pretty sure all of you might have learned about SQL, okay, like in your database classes or DBMS concepts or data mining or any class related to the databases. Probably you might have learned about SQL, right? Select, insert, update these statements. So Hive also um, support the SQL. So you could run simply SQL. If you want to access the data from HDFS, so if you have a Hive table defined on that one, so you could simply use SQL. You could say select a star from table. So Hive, what it does is, it will go to the HDFS and it will bring the data, okay, which is stored in a Hive table, and then it will bring back to you. So that much simple. Even I think I do have a slide for that. Let me quickly see that. Otherwise, I'm going to cover that right now. Uh, yeah, it does not have that one. First thing, Hive provides SQL interface. Okay, but Hive is not a database. Hive is not a database at all. Uh, at least one of the basic definition of having a database is because Database is something that which would able to store your data, right? In terms of databases and tables, that is one of the feature of the database. But and second one is second property of databases is okay, like so. Once you store the data into the database, it will allow you to use the SQL, okay, like to get the data, to manage the data, to store the data, to remove the data, to update the data, whatever. Okay, right? So these are the database features. These are the database things, how we would define a database. But Hive is Hive is a special element where it's not a database. It will not store any of the data at all, but it will provide a SQL interface. If you ask me, Professor, is there any database which will provide SQL and which will not store the data? I don't. There is none. Database means it should be able to store the data. That's what database is about. But a Hive is not a database. Again, Hive will not store any of your data. But using the Hive, you could write SQLs. Especially why the people have designed the Hive. Okay, uh, they want to remove the barrier between the data and its definition. Okay. Let's take before I come into what is a Hive and all the stuff. Okay, like so. Um, let's take a small thing. Let's take any of the database. Okay, typically in a database, uh, you create a table. So there is a table exists. So first, what you do, you create a table, right? And the next step is you insert the data into the table. And after that only, okay, like you could able to select the data or update the data like this, right? All the managing operations you could able to do after loading the data or after insert the data. I mean, I am using the word insert because uh, SQL provides that insert statement, right? Unless you insert the data into the table, you cannot do that one. But before inserting the data, you require the definition of the table. So without definition, I cannot add the data. Agreed? I'm pretty sure you might already have a little bit experience on the SQL, right? If not, let's assume that in a typical SQL world, first I need to create a definition. Then only it will allow me to store the data or to play with the data. So people, um, because of this property, it's becoming very hard and hard to manage your data. So before I insert the data, I need to know the definition. So what would happen? I will give you some small example, really. Uh, what would happen if I don't know the structure, but I'm getting the data? Also, when I'm getting the data, um, unless I receive the data, I don't know I don't know how many contents are there, how many fields are there, how many columns of data that it would be mapped into. Especially in a big data world where you are gathering the information from different sources, so it's very hard to know the definition before arrival of the data. Um, some people are not able to see that. Okay, like
Hello,
let me
Professor.
yes, sir.
Uh, See, you're receiving data from different sources, of course, heterogeneous. But the structure of the data from each source will, why you will not be knowing that?
Because source would be different and you are collecting the data, it need not be in the same format, it need not have the same number of elements and everything.
No,
Okay. So
that is true, Professor, but if it is coming from one specific source, you know the structure of that specific source, right?
correct. But sometimes what would happen is like you are getting the data from one source. So today you are expecting like 10 columns and you are getting all the 10 columns of data. But tomorrow from the same source, if it is not guaranteed to have 10 columns, maybe you may get 12, maybe you get 14, you may get like maybe 140.
Then
That
they
is the
don't give the new structure when, because
that's what
generally, uh,
that I mean. So you need to have a new structure and you need to alter the definition of the tables and
mm,
then only you could put the data. So that is the problem exactly. Like so,
okay,
I
okay.
just given
So
one example.
daily the structure keeps changing. Okay.
Daily the structure keeps changing. Yes. So that makes people difficult to manage the data. So because
Yes.
you need to know before definition, before you insert the data or anything like that. Sometimes what would happen is unless um, I receive all the data, it's very hard to know what is the definition. Here in the database world, I cannot store the data without having definition at all. There is no way, there is no provision to store my data without knowing the definition. So it's very hard in the big data world when you're collecting. You don't know really what kind of a format that would be. Maybe it is a text format, whether it has 20 columns, whether, how the columns have been split across. So these are all like many challenges. Okay, like I given only a couple of examples, but in the reality world, it's really hard. Okay, like sometimes it's not even um, um, break down continuously by line. Okay, like so in one line I'll get two columns, another line I get 40 columns, and third line I'll get like 20, fourth line I get like one or two, like that. So these kind of a things, whenever you are receiving from source, you may think that okay, let's save this data first, then later on we'll see that how we could define a structure. What they did is they try to break this relation between data and definition. So what they did is let's forget about the definition. Let's store the data first. So now I have all the data ready, and now I know that how many columns are there in the total data. Is it possible to define a table afterwards? So first store the data. I mean here in this example, first I will insert all the data somewhere, and then after that I can create a table. If that is the case, I know all the structures afterwards. Sometimes it's very hard to know before you insert the data. Right? You could think certain things, unless in the data, unless it is a database world, that is the only world where you will know the definition before that. Even in the databases, okay, like so, if you suppose you define a table with 20 columns first, later on you realize that it's required 24 columns. What we'll do is we'll go and then alter the table and then add four more columns. Then tomorrow is two more columns. Then again I will go and add two more. So altering the table, loading the data, okay, like it's all very big pain. Okay, like and suppose for the existing data, okay, like if you want to add more columns, whatever it is, okay, like so there are a lot of limitations like this. Only the reason what I want to highlight here is Hive would allow you to break the relation between data and its definition. Especially in the Hive, you could store the data and then later on you could define a table on top of that. Whereas in the SQL world, which is not quite possible right now, no database will allow you to create a table on top of the existing data. So that is the first barrier Hive was invented basically. That is the first thought that the people have realized the need for a Hive. If it is a SQL, why again we need one more tool like these features. So this is one of the features why Hive has been invented. Okay, like so, you might be wondering, oh, Oracle supports SQL, Sybase supports SQL, SQL Server supports SQL. Why again Hive? So all these tables they will not allow you to separate the definition from the data, whereas Hive would allow you to separate your data from its definition. We'll see that how I will allow that, and we'll have so many examples, and then it will be very clear. But that is the first thing. Second point is I'm not sure whether I highlighted or not, but Hive is not a database. Most of the people would think that Hive is a database. No, Hive is not a database. Hive will not store any of the data unless this system would have a capability to store your data. It would not be called as database at all. That is one of the basic definition of a database. It should allow you to store the data. Hive does not store your data. So Hive is not a database. It's simple. But Hive provides a SQL, and you could run your SQLs to get the data. That is the reason people would think that Hive is a database. But in reality, it's not. Is there any database which would provide SQL and does not store the data? None. In that case, it will not be called as database at all. Okay, so these are the main two components. Most of the people have a misconception on this one. Okay, like they all think that Hive is a database because they never saw any database which has SQL and which does not have any of the database features at all. So that is why people would think that Hive is a database. Okay,
Then where do you store the data, Professor?
HDFS.
In
HDFS.
SDFS only.
Yes.
Okay.
In Hadoop, there is only one place where you could store the data. That is nothing but HDFS. There is no other place in Hadoop where you could store the data. Okay. Um, and Hive has high level two main components. One component is called like parsing, another component is called for execution. Parsing, when you write SQLs, um, parsing part provides how you parse the SQLs and everything, what would be the syntax and all the stuff. I'm not sure how many of you really studied about automata theory. Basically, when you have anything, you have a language and you have um, a language means set of keywords that language supports and set of rules how you use this language, right? Similarly, even for SQL, for Hive, to parse the SQL, they follow the ANSI SQL syntax. So any SQL which follows the ANSI SQL that will simply runs in Hive. So Hive would provide ANSI SQL syntax. So if you know the ANSI SQL, typically that means you know the Hive. There is nothing. There is only small things you need to know behind the ANSI SQL. But if you know the ANSI SQL, I could say like 80% of the Hive jobs that you could do. Hive provides only the SQL. Okay, like whenever you heard some people that okay they use Hive to complete this Hadoop development project, that means they use only SQLs. And if you know the SQL, you could do the Hadoop development right away. Uh, Second part is execution. Sorry, execution of the query. So for execution, Hive has several options, like 3 or 4 options. So it can use map reduce engine, okay, like while processing your query or while executing your query. It may use stage stage framework while execution of your query, and also it has some Spark as well. But people, I think um, it's not been recommended to use Hive on Spark, but rather there is some other component in a Spark where you could use the SQL of Spark. Okay, but it has the stored. So data will be stored in either HDFS or S3. S3 is a uh, file system similar to HDFS. It's completely based on the Amazon cloud. So if you have any of the cloud-based system, okay, like um, that entire cloud will have a file system called S3. So we'll talk about whenever we have some time on discussing about cloud computing. At the time, maybe I can give you more details on S3. But right now, it just assume that it's similar to HDFS. Okay, it's another file system. Hive, you could also point to S3, and if your data is in S3, so still you could use the Hive, okay, like for storing up your data. And Azure is another file system. This is for Microsoft Cloud Storage. Okay, like so, if you have any of the Microsoft-based cloud system, and S3 is for Amazon, and Azure is for Microsoft. There is a called like GFS. It's called Google File System. That is for Google Cloud. Like that, there are a lot of file systems are available. But Hive, you could run any of these file systems. But in especially in the Hadoop world, people would use HDFS. Okay. And third one, uh, it's also very important. Um, since Hive is not storing any of the data, right? When you define a Hive table, like for example, even in the SQL world or anything, when you create a table, right? Typically, I will try to give you something here. Create table temp. Okay, I just given ID integer like student details and name string. So this is the typical create table syntax. So I given the create table temp, it has two fields, ID and their data type, int, name, string, and all the stuff. Remember, Hive is not a database, right? Hive will not store any of the data at all. So even when you create a table, even this definition, there might be some place to store, is it not? If you are familiar about Oracle, there will be some system tables where this information will be stored. I mean, here the temp is the table name, ID is the column name, and the data type is int. All this information also will be stored in somewhere. Okay, like even your definition also will store in some table. Whenever you run some create table statement or alter table statements, anything related to DDL or DML, that part will be stored in some table, some system tables, basically. It's not user level tables, it's called like a system table because the system would store the data into this table. But Hive is not a database. There is no way that like Hive would store this data. So that is the reason Hive would have another component. It's called like a metadata. Metadata is nothing but a data about your data, right? Your create table syntax, your column names, your data types of columns, and your storage component. All this information related to definition of your data that will be stored in uh, in a component called as a metadata. So all the metadata, don't confuse them much. All this metadata, okay, like will be stored in one of the RDB messages. So Hive has this a peculiar, a different architecture. So you could define your metadata, or they will call it as a metastore. Basically, metastore is nothing but where your metadata will be stored. So this metastore can be either MySQL or Oracle or PostgreSQL or even Derby or any other thing. So all this metadata, it will be stored in whenever you want to store, you need some database. Okay. So Hive is not a database. Hive does not have any of the storage component at all. But since it allows to have a SQL, when you select SQLs, it will allow you to create a table. Very simple. Create tables, create databases. It will allow you to create databases and create tables. So whenever you create a table, so even this definition, you must have some storage to store this definition. So that information, Hive has a facility to choose your own RDBMS where this metastore will be stored. So that metastore, PostgreSQL, anything, you could choose your own metastore database. Is it clear? I know it's a little bit, a little bit a tricky thing here, but just I want to check with you one more time. Is it clear, everyone? What is metastore? What is metadata? And why Hive required a DVMS to store this metadata?
So, Professor,
Yes, sir.
just to summarize, correct me if I am wrong, my understanding is generally in any place you need a database to store data. You need a query language to retrieve the query information, and you need a processing language to process the data that is obtained. That is the
The pro-
general way of handling.
process language is
So,
nothing but SQL itself. There is no other processing language required.
of course, SQL itself. So here, no, SQL is the one that extracts the data. But suppose you want to report for generate a report or process the data further, you use a host language, right? Like Java or something. So here I can say
Or to
the
retrieve that
query,
to retrieve the
uh,
data from database.
retrieve the data is SQL only. The
Okay.
retrieved data is further to be processed for reporting, right? That happens in language like Java or some reporting language.
Yeah.
Suppose I
Yeah.
want to generate a sales report from the
Correct.
database, SQL will generate the sales data,
Mm-hmm.
but you need a language to process it further, right?
Frankly speaking, it needed to be a language. You could use any of the tools as well, like
Tools
Tableau.
as well, right, right, I agree with you. Either
Okay.
tool or reporting tool or a language.
Correct. Yes.
So here, if you look
Here
at
also similar. Here also similar
similar
thing.
thing, I'm just drawing the similarity between these two. So
Okay.
for you to store database, you have a database like Oracle and all, but here the data will be stored in HDFS only or Azure or some file system setup. But in a database, you require a metadata definition. But here the metadata definition will not be there in HDFS, but will be stored in some database of your choice
Correct.
in this case. Am I
That's
right, sir?
that's absolutely right. But defaultly, I mean, when you install from Apache, okay, like open source version, defaultly it will be pointed to the Derby, which is called like a file system database. Again, that is a very old Java-based database. Um, but people would not use any file system databases, especially to store the metadata, because if you run a query, right, like select ID from a table, what it does is it will go into the table and try to get the definition. So every time it will hit that. Every time you're running the SQL, first it will try to get the definition, and then it will run your query. So typically it will take some time. Okay, so file
Yes.
system databases are not recommendable, but SQL databases are very much recommendable. And again, this is not to store your data, this is just to store your definitions, which will not consume a very big in size, very small. Okay, like so.
But it's not the question of size, but if you want to retrieve some data from this HDFS, you have to hit the metadata in the RDBMs. Probably will it store in the buffers then subsequently in order to
Uh,
avoid the query hits?
no, I mean the reason they use the RDBMS is that to support multiple users at multiple hits and all that stuff.
Yes,
Because it will
okay.
be much more faster. It will not be any delays to get your destination. We'll see that one anyway. Like I mean,
Okay, okay,
we do
Professor.
have hands-on exercises. Then we can see that exactly how
Okay,
where it will store this metadata. I will also show you
okay,
that.
okay, Professor.
Uh,
Thank you.
next one, is like using Hive. Typically, you could build a data warehousing system for Hadoop and big data. Some people would use Hadoop platform to build a data warehouses. Okay, like so, it's been using in the industry a very long time. But when you're building a data warehouses or data mart using Hadoop or big data, then Hive would play a very very important role. Okay, like so, most of the implementation or even development work would be in Hive in that case. Okay. Hive will also enable like ETL processing, like extract, transform, or loading. So you could extract the data some extent using the Hive, and you can transform the data from one format to another format using the Hive. Also, like you could load back into HDFS or any other formats. Also, like it just enables your ETL processing, but it's not ideal to use your ETL. ETL though. But we do have some other tools um, uh, where it will be more advantageous rather than using the Hive there. But Hive is much more ideal, okay, like to run any ad hoc queries on data. So if you want to just like a query like select a star from or select a group by, and if you want to join multiple tables, okay, like in that scenarios, Hive is ideal. Okay, I'll go to the next one. What are the features of the Hive? First thing, the first feature itself, a Hive is nothing but SQL. So it has a SQL interface and it supports all the SQL syntax. Again, when I say SQL, it supports ANSI SQL. In other words, the SQL which will be used in SQL Server database or the SQL which will be used in MySQL, Sybase, they all follow ANSI SQL, but not Oracle. Oracle will not follow ANSI SQL syntax. Okay, just to give you much more clear on that. Hive very easily it integrates with Hadoop and HDFS. Also, it integrates with HBase. Okay, like I'm not sure I'm going to cover this, but yes, um, you could store the data in HBase, and also you could define a high table on top of HBase data. That is also possible. You could have data in S3, even in MongoDB as well. Okay, like so that is also possible. Okay, that's it. Typically the databases which does not support SQL. Okay, like where you could take this high engine there, and then you could point to the data, and then you could use a SQL. For example, MongoDB and HBase. These are these databases does not provide open big data. Some people would use Hadoop platform to build a data warehouses. Okay, like so it's been using in the industry a very long time. But when you're building a data warehouses or data mart using Hadoop or big data, then Hive would play a very important role. Okay, like so most of their implementation or even development work would be in Hive in that case. Okay. Hive will also enable like ETL processing, like extract, transform, or loading. So you could extract the data some extent using the Hive, and you can transform the data from one format to another format using the Hive. Also, like you could load back into HDFS or any other formats. Also, like it just enables your ETL processing, but it's not ideal to use your ETL though. But we do have some other tools um, uh, where it will be more advantageous rather than using the Hive there. But Hive is much more ideal, okay, like to run any ad hoc queries on data. So if you want to just like a query like select a star from or select a group by, and if you want to join multiple tables, okay, like in that scenarios, Hive is ideal. Okay, I'll go to the next one. What are the features of the Hive? First thing, the first feature itself, a Hive is nothing but SQL. So it has a SQL interface and it supports all the SQL syntax. Again, when I say SQL, it supports ANSI SQL. In other words, the SQL which will be used in SQL Server database or the SQL which will be used in MySQL, Sybase, they all follow ANSI SQL, but not Oracle. Oracle will not follow ANSI SQL syntax. Okay, just to give you much more clear on that. Hive very easily it integrates with Hadoop and HDFS. Also, it integrates with HBase. Okay, like I'm not sure I'm going to cover this, but yes, um, you could store the data in HBase, and also you could define a high table on top of HBase data. That is also possible. You could have data in S3, even in MongoDB as well. Okay, like so that is also possible. Okay, that's it. Typically the databases which does not support SQL. Okay, like where you could take this high engine there, and then you could point to the data, and then you could use a SQL. For example, MongoDB and HBase. These are these databases does not provide SQL interface. but they will store the data. So Hive would address the gap of that not having a SQL interfaces. So you could you could store the data in HBase and you could define a Hive table and you could use the still SQL query to retrieve the HBase data. That is the beauty. And Hive is very easily you could extensible, like you could very easily extend the Hive thing, maybe type. If you want to create a new type in Hive, you could do that very easily. If you want to define a function in the Hive, you could very easily do that. And it will support multiple formats. Okay, like, and you could write small script as well, like that. It's very easy. You could easily extend the existing Hive script. Hive provides DDLs called data definition language. Okay, like you to create a table, to create a view, to create an index. Okay, like this. So it will simply follow the ANSI SQL syntax. And if you already know the SQL, it's pretty easy. Also, like you could select a star from table with where class and group by, order by, sort by. Okay, like these conditions you could use that one. The only important thing here is Hive provides both order by and sort by. Typically, most of the SQLs, like even Oracle or MySQL, they do have only order by. They don't have sort by. So Hive provides both. Um, Whenever we are running hands-on queries, at the time I will show you the difference between order by and sort by. Now, even if I explain, I don't think you could realize. But whenever we are running the queries with physical data, then we could see that very clear difference. Hive also provides a lot of joins, like inner joins, outer join, left outer, right outer. Okay, like so. They all follow ANSI SQL only. Nothing, um, nothing special special feature in only available only in Hive. It's pretty much follow the same syntax as ANSI SQL. Next one, um, the interesting feature is UDFs. So what are the UDFs? It's called like user-defined functions. UDF stands for user-defined functions. So very easily you could write your UDFs. UDFs are nothing but you could simply assume that there are some functions. So Hive has very rich set of functions. Um, Hive has so many functions basically. So, but you end up having some function which is not available, or some functionality not available in Hive. So people, what they do is they will end up writing UDF. UDF called user defined function. So I'm looking some function, like for example, I'll give you one example exactly like which I have written. So in one of the projects that I worked on, we need to know latest Saturday from the today date. So suppose today is Tuesday. So I would like to get what is the Saturday date, earliest Saturday date. Okay, like so. And if I run this command and tomorrow, even Thursday or Friday or even Saturday, if I'm running the command on the Saturday, so it should give me this next week Saturday date. So this is the date function basically. So I will pass today date and it should give me the earliest Saturday date. So for that one, I could not find anything on the existing Hive. So we defined a user defined function. How to define a user defined function in Hive? Remember, especially in the Hadoop world, any customization is possible by writing Java code. So, especially UDFs, people would write into Java. So this is the functionality. I will pass the date and it should return me the next Saturday date. So what I will do is like I will open up a Java program. I will write that program and then like I will pass the parameter. Of course, there is some syntaxes and all that stuff. If possible, we'll go through that. Otherwise, I would like to skip that one because it's part of the Java anyway. Any Java developer can easily write these UDFs. So once they write the UDF, generate the jar and use the jar in Hive, and then you could run that. It's that simple. So if you have a jar build, get the jar, load the jar into Hive, and then you can use any of the functions defined in the jar in Hive code. So that one's simple. I'll show you like some of the jars we do have, like so maybe I could show you that exactly how you could load the jar, and use the functions defined inside that. There are three types of UDFs again. UDF at the column level, UDF at the row level, UDF at the table level. Okay, so it's called like user-defined aggregate functions, user-defined table generation functions, user-defined functions, like that. Three different categories. So what kind of a data that it will be passed to the UDF is a matter. So if you want to define any function at the table level completely, okay, like then we could use user-defined table. At the row level, okay, like so finding out number of columns in a row or something like that, then you could define user-defined aggregate function. But if you want to define only on the particular column value, okay, like so I'll pass a date, then you give me the date like that. So one column, particular one column, then it will be defined as user-defined function. Some of the UDFs you could run them both on the column level and also the row level. Okay, so they're about features of the Hive. And another interesting feature available in Hive is called like a partitioning. So this is the new concept in the Hive, so which will allow you to partition a table. Even in the Oracle SQL Server also, people would call it as a partition, but little bit different from their partition to Hive partition. Okay. Um, as the name indicates, partition means it will try to separate out the data based on the partitions that you create and table. So your input data volume would be different if you use partitions or without using partitions. We'll see that more when we are practicing some hands-on queries, hands-on tables like that, how to create the partition table and all that stuff. Okay. I'm just highlighting there is a feature exists. Okay, like so in Hive. Another one is called sampling. So Hive will allow you to sample some of the data. So if you have like 100 rows, so you can just get the sample of 10, sample of 5, like that. Okay, which will be another interesting feature which normal normal SQL databases does not have is called like bucketing. Bucketing is also very interesting, and typically it will be used to increase the performance of a query. Um, we'll go through that whenever we have some more hands-on thing. So unless we create a table with bucketing and we'll try to query the data and then we'll see that what will be the difference and all this. I have a very good number of examples on all these things. So we'll run everything altogether. Um, Various joins and optimizations. So when you're defining a joins, okay, like so you could define like map only joins and memory. You could store one of the table data into the memory. Okay, so that your query will be performance and the vectorized joins like that. There are a lot of features available when you are joining multiple tables. Okay, like especially when you're optimizing the query performance. And also it has a feature called unmaterialized views. It's not only materialized views and unmaterialized views. Hive does not have the concept called materialized view, but all the views in Hive are non-materialized. Non-materialized means the data will not be persisted. Materialized means it is a Hive, it's not a table, but data would be persisted. Okay, typically it will act as a table. Hive also supports complex data types. Like typically in the SQLs, we have integer, string, okay, like right, a float, double, boolean. Typically, they are the only the types. But Hive supports arrays. You could define an array data type in Hive. This is very handy. And also structured data type. Struct. If you want to store your address, it has a street name, house number, city name, state, pin code. So altogether, it's called like a structure. Okay. Another data type is called like a map. Yeah, it's just like a Java maps. So you have a key value pair, like that, right? So we already covered hash map, linked hash map, like that. So that map type, Hive also supports data type called map. So you could store key value pairs effectively in a map. in as a map in using Hive. So while creating a table itself, you could say create table, employee name as string, address as struct, and uh, number of subordinates information as an array, and salary details or tax deductions as a map, like that. I do have a very good, nice example on that. We'll also see that one. Hive also has a feature called indexing. You could index the data in Hive. It's not there in the old versions of the Hive, but it's very newly it's been added. So Hive also has a feature to create an index similar to your traditional SQL databases. Hive, you could also integrate with HBase and other storage handlers. I think I already explained that one. You could also write your own format. Suppose your format is something else, okay, like that you define the format, like storage format. So you could write a Java storage format class, and then you could use that one. You could use that Hive, and then you could define a Hive table on top of that. That's how people has defined this customized storage format for HBase, MongoDB, and this kind of a different storage formats. And oh, another thing, maybe I don't think I covered this. What Hive does is high level will convert your SQL query into a Java MapReduce program. That's what Hive does, nothing else. So whenever you write a Hive script or SQL, when you submit, when you run that your SQL query, Hive, what does it mean by the parsing? So it will parse your SQL and convert your SQL into a Java MapReduce program. That's what Hive does. And then obviously Java MapReduce program would be run on the Hadoop platform, and then it will run the cluster, and then okay, like it has the mappers, reducers, and everything, and then it will produce the data back. Remember, unless it is a unless it is a MapReduce, you cannot run on the cluster. In other words, unless it is a it has been written in a way, okay, like uh, to run in a distributed manner, you cannot run on a cluster. So in Hadoop platform, everything is distributed, right? So unless your total job would be divided in terms of the mappers and reducers, you cannot run on the cluster. But writing into a Java MapReduce, okay, like it's not an easy thing. You already saw that a word count, okay, like even to write a simple word count, okay, like how many different classes that we need to add and all the stuff. But not all the people are really familiar about writing a Java MapReduce. Unless you are a Java developer, you cannot run, you cannot uh, write any of the Java MapReduce program. To avoid that gap, so people build this Hive engine. So in Hive, if you know the SQL, you write the SQL. The rest of the things it will take care of the platform. So Hive, what it does is it will convert your SQL programs into a Java MapReduce and then produce the Java run program into the cluster and then run. So all your SQL statements. Yeah, I would have added that point really. I missed that. So if you want to have your own mapper and reducer, okay, like you could also specify that. Okay, when you're running the query, okay, like you could say that use this mapper class, use this reducer class, and then run my query. It also does that. That's what the last sentence means. It has a custom map and reduce scripts, and also pluggable Serde. Serde is a very common word used in the Hive. Okay, like it's called like a serialization and deserialization. That's what the Serde means. Serialization and deserialization. We'll see that whenever we have the more hands-on thing. Okay, like I know I have given a lot of jargon here. Um, how can we connect to the Hive? Okay, like so, a lot of options because of the SQL syntax. So one is called like a Hive shell. Okay, have a Hive shell. Uh, Typically, whenever you log in into your HDFS, edge node, type Hive, okay, like it will take you to the Hive command line interface. That's called like CLI. CLI stands for command line interface. Whenever you run the Hive, it will give you the Hive prompt. Maybe it's taking some time here, but it will come out. And the next one is beeline shell. Um, Hive also has another type of shell. Okay, this is a Hive. You can see that one. There is a Hive prompt, and then here you could run all your anticicle anticicle commands. I could say. One of the things is called like show databases. It will give you how many databases, what databases it exists there. And I'm increasing the text size. I know some of you is not able to uh, see that clearly. Just run, just run the Hive. Okay, like which will take you to Hive command line interface and it will give you the Hive prompt. There you could run all the databases. I have the show databases. It will give you what are the databases exist in the Hive. Again, Hive is not database, but in the Hive terminology, they'll call it a database. Like even in the Oracle also, you could create multiple databases. Is it not? Or like multiple schemas. Here the database is nothing but schema. And inside the schema, okay, again you have a several, again you have the table. For example, I have a class here. So use class. This is how you specify a particular data, the list of the table. Show table will give you the list of the tables available in this database or in this schema. Similarly, there is another one. Don't worry, we have some more weeks time, and then we'll be pretty much comfortable in doing everything there. Um, Another way accessing your Hive is called like a beeline. Right now, just assume that there is another shell. It's called like a beeline. Here also you could use show databases. Uh, no correct connection. Okay. Yes. For beeline, you need to have connect. Not sure whether I do have. Um, I don't have the syntax, but yeah, you need to connect in the beeline. We'll work on that. Basically, I don't have the syntax on top of my head. This is another way of like getting the running your Hive program. Third one is called like using the JDBC driver. So any tool which has some support of the JDBC, like using Java, Scala, or any other programming language, you could use JDBC driver and then you could connect similar to how you are connecting to any other database. Okay. And ODBC driver, yeah, some applications will support ODBC, like open database connection and Java based connections. That is the difference between these two. And also fifth one is the like Trust client. If you have any of the client use followed by the Trust server, okay, like you could also use that. Most of the people they don't use the Trust client. Most of the applications they use either JDBC or ODBC, external applications. So this is how reporting applications will connect to the Hive, like Tableau, uh, Talent, Informatica, uh, Cognos, maybe probably. Okay, like or maybe not Cognos, Informatica, all these tools they use. Even you could connect using Microsoft Excel. So Excel can connect to the Hive and then get all the data to Excel directly. So Excel uses ODBC. Uh, DBWeb, that tool uses the JDBC. WinSQL, that uses again ODBC. So one of these drivers they use it, and you could connect to the Hive directly. Um, yeah, if time permits, I'll show you even how we could connect the ODBC. Okay. With this process flow, I will stop for today. Okay, like so, just bear with me, and then this is the process flow used in the Hive. You could use HiveQL. HiveQL is nothing but people, they don't want to use the SQL, they use the HiveQL because they want to differentiate between Oracle or MySQL script to the Hive. That's why they use it as a Hive query language. Remember, Hive supports everything from ANSI SQL and also addition to that. So that's why the people would prefer to use as a Hive query language, HQL or HiveQL, anything that you prefer. But as such, syntax is not, file name extension is not a critical thing for Hive. Even if you could save as a text, you could save as ABC, you could save as any other file, but you pass to the Hive, it will execute that. Only thing is the content should be in SQL, not the file extension. Here I have given some more examples, which tools we use, how they will use it, all the things. Uh, Three components, it has a compiler, nothing but called like parsing thing. One is the executor, which is the execution part. There is an optimizer part as well. So whenever you run some Hive query after parsing, after compilation, uh, that means it will be converted into a Java map reduce program. So it has some mechanism to optimize the number of mappers and reducer jobs also built into the Hive. When you use the Hive tool, um, it directly uses the Hive API engine and then it will generate the data. So whereas if you use the Beeline use the JDBC and then JDBC will use the Hive server 2. There is a server called Hive server 2 and then internally it uses the Hive API. But at the end user, you will not see any difference. So if whether you use the CLA Hive, whether you use the CLA Beeline, whether you use the any of the web UI, and Hive also has the web UI, by the way. And there is a Hue, it's called like a Hadoop user environment, and there is a Ambari views, and or else you could use Excel, Tableau, Talent, Informatica, or any other tool which has a facility to connect to the Hive using JDBC or ODBC. You could run all your Hive queries. So there are a lot of options, lot of ways how you would run Hive queries. While execution of your query, Hive would use three different type of frameworks. One is called like MapReduce, or Tej, or even the Spark. Whenever you run this MapReduce or Tej and this one, obviously um, uh, it uses the yarn part. Okay, like it has the name node and data nodes. It has the resource manager and node manager. So submit all your jobs to the resource manager, and then it will be executed on using the node manager where your data would be stored in the Hadoop side. So this is the overall flow. What would happen in the Hive? I missed one of the things. It's called like a metastore. So Hive, all your definitions of the tables and databases would be stored in this metastore. So this is this metastore can be any of the RDBMS like MySQL, Oracle, PostgreSQL. Um, I think these are the three topmost databases that they will be using. Most of the clients that I worked on, they do have the Hive Metastore as MySQL. MySQL is the very famous one. Some people use PostgreSQL as well, but most of the people would they use either MySQL or PostgreSQL. Only one client they are using the Oracle, but most of the clients they use MySQL as a Hive Metastore. This part. This is the overall flow. So whenever the user runs some Hive queries using one of these methods, like using HiveCLI or Beeline or using WebUI or using any other external tool, so that query will be submitted to the Hive, and inside the Hive there will be a compiler and there will be an executor, there will be an optimizer, and then it will try to use just one of these engines while executing. But your job would be executed in cluster. So whenever you run Hive query, you could see that job in the resource manager. So finally, that query would be converted as a Java MapReduce. Java MapReduce would be given to the cluster, and then cluster would be run, and cluster would be able to run your MapReduce program and generate the results. But only the beauty thing is here you need to write Java MapReduce. If you write SQL, that would be enough. That means you could do some extent of Hadoop development. Hi, Metastore. Typically, it will be backed by RDBMS. There be MySQL, PostgreSQL. It's not recommended except for a quick POC. POC is called like proof of concept. Otherwise, uh, most of the clients, they use one of the RDBMSs. Okay. Metastore has different modes, called local mode or embedded mode or remote Metastore as well. So when you say like remote Metastore, if you use the MySQL, this MySQL need not be on the same machine where the Hive has been installed and like that. So it can be remotely. It can be available in some other node or some other system or some other cluster, some other data center. Okay, like you could configure that.
Professor, a small query.
Yes, sir. Sure. Go ahead.
Uh, the thing is, generally we use uh, SQL for retrieving the data from database and we use it for further processing or reporting or whatever it is. Okay. Here, uh, retrieving you are doing through Hive. Okay. Then in Hive, you have the features of structures, arrays, and all, right? So that means you can process the data after retrieving from the database or from the HDFS rather
No. I mean,
through Hive.
even arrays, structure, map, they're also part of your SQL itself. They're not another layer in SQL. They're embedded.
Actually, SQL doesn't support arrays and all. Only the language part further.
No, no,
Because
no,
if you consider Oracle, PL SQL is the one that supports arrays and other stuff.
no. Here array means it's a little bit different. Okay, like so, it's a part of SQL itself. I mean,
I see.
part of the SQL in the sense like typically ANSI SQL does not have array data type, but Hive has. So that's what I'm saying. Hive
I
will have
see.
ANSI SQL and beyond ANSI SQL. Okay, like
Okay,
there are
okay.
additional features of SQL in Hive. One of the thing is called like support of the different custom types like arrays, structure, maps, and all the stuff.
I see. So in this case, it is easy for you to handle because you have more features. In
Correct.
SQL itself, processing is also embedded.
Correct. I mean, the only reason is that why Hive has all this kind of a support because their definition is different from the data.
Okay,
Problem for
okay.
SQL databases is even though they want to give you a support for array and that thing, it's not easy really. Like,
Hmm.
that is the reason they want to break that basically.
I see,
The
I see.
strong relation between your data and definition.
Uh,
Okay.
Right. Pivot is a feature included in SQL from 11G onwards that facilitates some kind of table handling, right? In a similar way.
Yeah, I could say Oracle is 30 years old, but Hive is just like 4 5 years, 6 years
Of
old.
course.
Anyway, I have a question from JNTU Vijayanagaram. Okay. Typically in a Hive, this metadata is also a part of Hadoop cluster. So, when you end up using MySQL as a Hive metastore, so MySQL also will be installed in one of the nodes of Hadoop system. That's what people would go. You need not install MySQL, but if it is already installed, available in your company in some other data center or some other node, you could also use that. You could also leverage using that MySQL. If you don't have it, you could install it.
Professor, probably his question would be where the metadata will be stored. I think metadata could be
Metadata
stored
will be
on name node.
sorry, no. This is Hive metadata. Hive
I say
metadata.
high metadata. Okay, okay.
So Hive metadata will be stored in the metastore itself. Okay, like so that is called like a RDBMS database, like MySQL or Derby or PostgreSQL or Oracle. Whatever the my metastore database that you configure, that's where the Hive metastore is going to store. Here, the Hive metastore means definitions of your table, definitions of your databases. When you say like create database or create table, so where this definition would go into, that that definition would go into this metastore. like equivalent to the system tables in Oracle, system tables in MySQL, like that. Uh, there is a there is other keyword in MySQL. What do you call that? System tables. Something I forgot that word. Yeah. Most of the system table related things will be stored in the metastore.
So this metastore physically lies on where the hive lies, right?
Yeah, it need not be in the same node. It can be other node as well. But the only thing is, if it is able to connect from that node, that would be interesting.
What will be the typical size of this metadata?
Very small, sir. Very small. Very
Then
small.
why don't you keep
Same node. Um,
how does it impact the process?
that's a really good question, but I'm not sure really. Like, why is it? I mean, name node is completely different. That is only on HDFS
Of
part.
course, that is for
This is they try to store in terms of tables, basically, like system tables are
right,
when you
right, right. It doesn't make sense on keeping a name node because name node is HDFS internal feature,
it is
whereas
only
your Hive is on top of it.
correct.
Okay, okay.
Is it clear, JNTU? Vijayanagaram? Sorry. Okay. Yeah, next class we'll cover, we'll see more things about Hive. I do have a lot of slides and I do have a lot of queries as well. Maybe next class we'll try to create our first table in Hive, and then we can go and we could see that one, how to create a table, and how to use array, how to use structure, how to use maps in create table, how my how I could separate out my definition from the data. So that things we'll see in the next class, and then we'll continue our journey of Hive. Any more time?
Um, Actually, if there is a logical end, you can stop here, no problem. Just up to you. Otherwise, you can answer some queries.
Yeah, no,
Because even if you
two-way by using H catalog, service. So you store, you create a table in Hive, but you want to store, you have created a table using Hive, and you want to store the data using Pig. So in that case, what typically people do is uh, they'll they'll get to know what is the definitions of the Hive table. Okay, our definition of the Hive table, or at least they need to know where the location is, location about the data and all the stuff. So to avoid all these things, people they people they created this service called like H catalog. So it will simply in H catalog you could say that this is the Hive database, this is the Hive table. So you need not know about the definition, you need not know about the table details, location, and everything. So internally, Pig will get the definition from the H catalog, and then it stores the data back into the Hive table. So that is the main purpose. It will expose as a RESTful web interface or web interface. So internally, it will call the web service call, and it will get the data. Uh, everything it will start using the web, okay, using HTTP protocol. So that's why it's called like a web HCAT web HCAT or web HCAT. So a small web server, okay. Um, Internally, all the Hadoop daemons has the ability, okay, like to respond for any of the web service. So they have internal RESTful web services which will be invoked, or you could also get the response, okay, like by calling them as well. So if you want to store the same information, okay, like from the different ecosystem elements, you could enable HTML. Earlier, it was an optional, okay, like people would enable it by passing some of the parameters, but from the past, 1.5 year or 2 years. I think it was part of the Hive itself. So whenever you create a Hive table in Hive, so it will be available in HCatalog. So they synced up both Hive and HCatalog, and you could easily get from that. Whenever we are writing some big scripts, at the time I can show you exactly like how you could access the Hive table in Pig using HCatalog. But it just right now we just assume that there is a concept called HCatalog. H stands for Hive only. It's called Hive catalog. They not name it as a metadata. They would have made like H metadata or something, but catalog they name it as a catalog. It will give you Hive metadata name and table name, and it will give you the definition. Just what fields are there in the column, what their data types, and that kind of information. H catalog will provide. Yeah, this one I'll before I come here, I want to all of us they would create some tables, would load some data, would run some SQLs, and then after that I'll come back. I'll resume back, and then we'll continue the further slides. Any questions? SQL.